All right, so you guys have now been through all the essentials for the sine law and the cosine law, and we're going to get into the extensions, and really the big topic in the extensions is the ambiguous case of the sine law. So we're going to talk about what that is. So in order to understand it, you have to understand a couple things about sine. And one thing that you have to understand about sine x is that the sine of 30 is the same thing as the sine of 150, all right? Or the sine of 60 is the same thing as the sine of 120. And I want you to take your calculator and just try these, okay? You'll end up with, this one will give you 1/2 in both cases. This one will give you √3/2 in both cases. Try any combination of angles. I'm just picking ones that we're familiar with, but this is the sine of 45 and 135. Any combination of angles that adds up to 180, so supplementary angles, one that's acute and one that's obtuse, and you will end up with the same answer on your calculator. And you can pick any, I don't care what your favorite angle is. If it's 20, then it's 20 and 160, but you will notice that they're the same. And that causes a problem for us when we look at solving the sine law, okay, because the sine law looks like this. And if we are trying to solve for an angle, you guys remember that you're going to go sine A is equal to A sine B over B. In other words, you're just going to bring that up. And then, and this might look a little unfamiliar to you because of the no numbers. Okay, I'm writing in letters, but you're going to then take the arc sine to get A. And this is where the ambiguity happens. Because the sine of 30 and the sine of 150 are both 1/2, or the sine of 60 and the sine of 120 are both √3/2, if, for example, I get A to be the arc sine of 1/2, there's actually two possibilities. It's possible that the answer is 30. And that's what you'll get on your calculator. Okay, that's what your calculator will tell you. Because your calculator is designed to tell you the smallest of the two. But the other possibility, we can say, or it's also 150 degrees. Okay, and in general, it's 180 minus theta if that's theta. So in other words, it's 180 minus the angle you find. So there's two possibilities. Okay, if you want to see it visually, because sometimes that helps, what we're doing, you just take a graphing program like this. This is just graph 4.4, but I'm going to just type in sine x. I'm going to show you the picture of what sine x looks like. All right, it looks like this. Now I'm just going to change my axes to degrees because you guys are used to working in degrees, and then we're going to go, and I'm just going to look from 0 to 360. Actually, 0 to 180. Let's do that. Okay. So here's my graph from 0 to 180, and you'll notice something about sine x. See how it kind of comes up, and right in the middle, it's at 1, and then it jumps back down. If I say sine x is equal to 1/2, so let's put in 1/2 here, and I'll just change the color so you can see this a little bit easier. Let's say it's yellow, okay? Then there's two places. Do you see what I mean? There's two places where it hits. There's two intersection points. And if I ask the calculator on here to evaluate the intersection, it will tell me the intersection's at 30 and 0.5, or it's also at 150 and 0.5. And it doesn't matter what value you put in here. I can change this value to anything I want. Let's say it's 0.5. Okay? There will be two answers. There's 20.48 and then 159.51. Okay, and you'll notice that those two angles add up to 180. So there's always two possibilities whenever we're finding the arc sine. And that happens, okay, we do that when, so when does this apply? We do that when we are having a situation where we have side-side angle. We have two sides and an angle. Okay, so when does this happen? That's when, when do I have to look for it? All right, and it happens when you're given side-side angle. So that is, you're given two sides. So if I draw a triangle, I'm given a side, let's say A, I'm given a side B, and then I'm given an angle. All right, and we'll call it capital A. So we're given an angle over here and two sides. That's when this happens. That's when we have to consider the ambiguous case, because we're not sure if the angle is 30 or 150. In other words, we're not sure if it's an acute angle or an obtuse angle, because it could be either one. All right, so hopefully you understand what we're saying. I'm going to do a little more in-depth analysis here of this. How do we figure out when that happens, or how many possibilities there are, or what we're even talking about? So visually what's happening is, if you're given side-side angle, and we'll just do an example. Let's say I give you angle A is 30 degrees. We'll say A is 4 meters, and then B is 12 meters. Okay? So here's what we're going to do. We're going to try to draw the triangle, but I don't know everything about the triangle. Okay? I'm going to call this angle A. So that means this side over here is little a, and I'm going to call this B, so that this side is little b. So what I know is this is 4 meters, and this is 12 meters, and this is 30 degrees. Okay, that's one possibility. The other option, possibly, potentially, is that the triangle could look like this. Okay, where this is A, this is B, this is side A, which is 4 meters, this is side B, which is 12 meters, and this is 30 degrees. And what we're saying is we could either have an acute angle for B, or we could have an obtuse angle for B. All right? So how do we decide if we have an acute angle only, if we have an obtuse angle only, or if we have both as possibilities? And here's what we do. Okay, so to check how many triangles are possible, we're going to pretend for a second that we have a right angle. Okay, so we're going to say, to check possible number of triangles. How do we know how many triangles? It could be that there's none. It's possible that, given this information, there's no way we can do it. It's possible that there's only one, and it's possible that there's two. Those are the three possibilities. It's possible that this side is too small to even form a triangle. It's possible that it's only one, it's going to form a triangle, but there's no ambiguity. In other words, it's not ambiguous which one we have. It's just there's only one possibility. Or it's possible that there are two. So how do we know? And here's how we know. Imagine that this is my triangle. Okay, I have a right angle triangle here. And let's say that's B, and this then is little b, so that's 12, and this is 30 degrees. Let's find A in this triangle, okay? But instead of calling it A, because I'm going to compare it to A in a second, I'm going to call it H. I'm going to say, what's the perpendicular height? In other words, if this was a right angle triangle, what would the height be? And we're going to find that by going right angle trigonometry. The sine of 30 is the height divided by 12. So the height is 12 sine 30, okay? And that is 12 times 1/2, if you do your sine 30 on your calculator, and that gives me 6 meters, okay? So in order to make a right angle triangle, which is the smallest distance, it's the shortest distance that we can have for A, it's got to be at least 6. What is A in our situation? So we're going to compare our height that we just found, h, to the given A value. All right, so our A value that we were given was 4 meters in our example, and our h value is 6 meters. Okay, and here's what happens. If the height is bigger than the A value, there's no solution. There's no triangle that works. Okay, which is our case. A is smaller than h. H is bigger than A, so we say there's no possibilities. If h is equal to A, then there's one solution. All right, and it is the right angle triangle. And if h is less than A, then we have 2 solutions. All right, so just to sort of graphically show this, what happens is if A is less than the height, then you have this side and it doesn't come down. It's not big enough, so it never is going to touch. Okay, no matter where we swing this, it's not going to touch. If it's equal to A, then it forms the right angle triangle. Okay, but it doesn't go anywhere past it. If it's bigger than A, or bigger than H, sorry, if A is bigger than H, then what happens is you actually form this triangle. Okay, and I'm sorry that it's not exact, but you have this extra little piece. And so what ends up happening is you either have to take that piece and swing it out, okay, which makes an acute angle over here, or you have to take that piece and swing it in, which makes that an obtuse angle. All right, so that's how you decide whether or not you have 1, 2, or no solutions. And we're going to do some examples of that, but I have to stop the video there just because of the time. So I'm going to stop the video there. I'm going to make another one to show you some examples of this and show you how to apply the sine law ambiguous case stuff to actual questions.